So here's an example of graphing polynomials, and again, if we talk about the polynomial video 1, I talked about trinomials in x squared, and this is what we have, is we have a trinomial in x squared. So if you say something like this, you'll probably want to factor it. So if we look at this, we know this would factor to b, since it's in x squared, and 4 is twice 2, so you can kind of get the idea that we do have a trinomial still. We can factor it as a simple trinomial, except instead of having x here, we have x squared, and you can always check it. X squared times x squared is x to the 4th. Minus 4 and minus 8x squared is negative 12x squared, and negative 4 times negative 8 is positive 32, so this would factor. It's just like factoring a simple trinomial. So the zeros would be anything that makes the value of f of x 0. That means the vertical position is 0, or it's on the x-axis. Okay, there's a graph, just to see it. So if the value of y is 0, that means it's going to be on the x-axis. So we call those roots or zeros, or x-intercepts. They're all the same. Points that are on the x-axis. Roots, x-intercepts, or zeros, all the same thing. So whatever makes this 0, so if this is 0, 0 times something is 0. If this is 0, 0 times something is 0. So we just set each of those equal to 0 and solve those simple equations. If I add 4 to both sides, x squared equals 4, so x equals plus or minus the square root of 4, which is plus or minus 2. Or x minus 8 equals 0, so x squared equals 8, so x equals plus or minus the square root of 8. Now 8 is the same thing as 4 times 2, and the square root of 4 is 2, so I can simplify that as 2 times the square root of 2. So you have to remember how to simplify your radicals. Remember, we know that 8 is the same thing as 4 times 2. And the square root of 4 is 2, so 2 times the square root of 2, just in case you got lost on that step. So these are my zeros. X equals 2, x equals negative 2, x equals 2 times the square root of 2, x equals negative 2 times the square root of 2. And we can write this, and we can either use the square root of 8 or 2 times the square root of 2, and we can write this as factors. Remember, each factor is x minus the 0. So x minus 2, x minus negative 2, which is x plus 2, x minus the square root of 8, and x minus negative square root of 8, which is x plus the square root of 8. Or we could write that as 2 times the square root of 2. Now, if we want to graph these, so these are my 4 factors. Notice the multiplicity is all 1, so they're going to be crossing the axis in each case. Let's see here. So if we want some approximations, remember we've talked about this before. The square root of 1 is 1, the square root of 4 is 2, the square root of 2 and the square root of 3 are between 1 and 2, so the square roots would be approximations in between those. And for the square root of 2, we usually use 1.4. It's actually 1.414, but just 1.4. And for the square root of 3, we use 1.7 for approximations. So if I put 1.4 in for the square root of 2, 2 times 1.4 is 2.8. So I can use those for approximations, and that will give me a better line on how to plot my points. So these are the zeros that I'm going to use to graph. And now the y-intercept, all I have to do is put, that's going to be just f of 0. And if I put 0, every time I see an x, what happens? Well, this is 0, so I just have 32. So when it's in this form, expanded form, or what we call standard form, when it's in that form, it's real easy to find the y-intercept, because that's just when x is 0. 0, 0, 32. So that's just going to be 0, 32. So I'm going to try to graph this. Now we're going to look at our end behavior function. All we have to do is add up our exponents. We've got 1, 1, 1, 1, so that's going to behave like x to the 4th. That is positive, even, so that's going to behave like x squared, which is like this. There's only 4 possibilities. They either behave like x, negative x, or x squared, or negative x squared. So only 4 possibilities. So when I drew my graph, my axis, so I could graph it, I had to do it by scale because sometimes the intercepts are a little bit high. So I made this by 8s, 8, 16, 24, and 32. And I'll mark my y-intercept, 0, 32. Now I know the end behavior is going to be like x squared, so it's going to be going up to the left and going up to the right. Or approaching, as x approaches negative infinity, it's going to be approaching positive infinity. As x approaches positive infinity, it's going to be approaching positive infinity. So it's up like that. And my 0, I'll mark my zeros in, and my 0 would be negative 2.8, which is a little closer to 3, negative 2, and then 2 and 2.8, so I'll put those zeros in. So those are those zeros. And I know in each case it's going to cross, so I can put a little mark like this, so it's going to cross. It's going to start here, it's going to come down and cross, it's going to cross again, it's going to go up to the intercept, come back down, it's probably going to cross over here, and it's going to cross back over there, and it's going to end up following the end behavior pattern, so that's a good way to check it. So it's going to kind of dip like this, so I'll make it up a little steeper, so it might come down like this, cross, come back up, and then it's going to go through the intercept. Now we can always check this, since these are symmetrical, I'm going to assume that it's going to go right through the intercept. It's not, and that's going to be probably a peak point. And it's going to come back down. Just because that's right in between. They don't always behave like that, but that'd probably be your best guess in this case. It's going to come back down. It's going to cross. Now we don't know how low it's going to go unless we put a value, maybe negative 2.5 or 2.5 in to find out how far down. So I'll just make it symmetrical to this side. Actually, it is symmetrical because it's an even function. All the powers are even, so we'll talk about that later, and it's going to go back up. So and we'll put some little arrows here to indicate that it's going back up. And that's the best guess you can do with this function with the information we have. So that's how we would graph that. And remember, it crosses when the powers are odd, and it touches and returns or bounces when the powers are even of our factors. Since these powers are all odd, 1, 1, 1, 1, it's just going to cross in each case. Okay? So I hope that makes sense. It should be symmetrical. Pardon my sketch if it's not. Looks like it's a little flatter over here, but it should be much more symmetrical. So I use a pencil when I draw the graph rather than a pen. It may be a little bit more difficult for you to see, but something like that. Okay? So I hope that makes sense.